The cast diagram. Okay, this used to give me so much trouble, and it almost gave me it again when I was making this lesson, because I think it's something that's completely skipped over and actually is responsible for a lot of marks. It actually comes up a huge amount. So I think it's really important that we actually understand what the cast diagram is doing and how to use it, and from that it makes the whole process of solving problems much easier. So basically, what is the cast diagram? Well, it's basically a way. It's a way for you to know what value you're going to get when you for each angle. And when I mean what value, um, when we just did this in our previous lesson. We looked at all these angles, okay, but we're only covering 30, 60, 45, 90. What about these angles that are not in this first quadrant here? They're not they don't all fall in here. But we think about if I say to you, right, what is the sine of um 200 225 degrees? Okay, well, you think, well, 225 degrees, that's about here. Okay, so it's negative something. But how would we go about figuring that out? Um, well, what we have is the sine diagram, the cast diagram, and what that tells us, it tells us the sign. When I'm going to say sign, I mean positive or negative, of the value you get at that angle. So here you get a value of around negative 0.5. And the way it works, right, is I've drawn the three big trig diagrams in this graph here. So the blue is sine, green is cos, red is tan. Okay, and what you can see is that for the first 90 degrees, all of these values give a positive answer. All of them give a positive answer. So no matter what angle you choose between 0 and 90, every trig function is going to give it a positive answer. But what happens is when you move into the next quadrant, so there's four quadrants, quad, so between 90 and 180, you can see that that cos goes negative here, and tan does what tan does, and it flips down to negative infinity at 90, and then it goes, and it's also negative, right? So you can see the only one that's positive is sine, and that's why it's called the sine quadrant. The second quadrant, sine is positive between 90 and 180 degrees. And if we carry this on to the blue quadrant here, we can see that actually at this point sine crosses the x-axis and goes negative. Cos is still negative, right? But tan has come through, and tan is positive. Tan will give you a positive value. And then again we get the fourth quadrant, and tan has done what tan does and drop back down, and sine has continued to be negative right up to 360 degrees. So basically, the way you think about it, right? So if sine is the only thing that's positive, therefore cos and tan must be negative. Same here. Tan, if tan is positive, then everything else must be negative, right? Same in cos. If cos is positive, then everything else must be negative. This is only true for the other three quadrants, apart from the first one where everything is positive. And when we talk about angles, what we do is we measure angles around this quadrant, and we measure them anti-clockwise, starting at 0 here. We go through these quadrants like this, and then we go all the way back to 360. But if you're at a minus angle, you actually travel the other way, right? Yes, you measure clockwise like this. So that's the main things you want to take away from this. It's really quite useful once you get the hang of it, and we'll go through some examples, and hopefully everything becomes a little bit clearer.